Good morning, ventilation unit, heat recovery ventilator. How important is it to properly select the operating parameters, the airflow in cubic meters, and the available pressure in pascals? I'll show you the differences between the products, from RENET, the REQ series and the Easy series. I'll answer the question, is it worth investing in an enthalpy HRV exchanger in a heat recovery unit? So, we already know how to install the system, and now we should choose the right device for it, meaning the heat recovery unit. Remember, at one point during the air balance discussion, I mentioned that we would also need a second value, that second value regarding the resistance of the system or the resistance that the installation creates, so that the heat recovery unit is able to overcome all of that resistance in the system. So, we need to select the ventilation unit based on two parameters, capacity and the resistance of the system, that is, according to the available pressure. We need to select, the operating point, meaning this operating point should be the result, here, sort of the intersection of these two, parameters, that is, the available pressure and the airflow rate. Ideally, this available pressure, or rather, this operating point should definitely be below, the fan's limit curve, and optimally for our installation, it would be best if this operating point is around 80 to 90% of the maximum capacity. And just like, for example, on the performance curves, on the capacity curves of recuperators, whether it's REQ or Easy. That's how we can properly look for this operating point, meaning, in fact, the recuperator that will meet the requirements of our installation. A new generation of intelligent recuperators. The company RENET conducted research, analyzed the available solutions on the market, identified the needs of users and installers, and developed the concept for a new range of recuperation devices, meaning the premium REQ series recuperators and the standard recuperators, which is our second Easy line. And let's see what makes these recuperators stand out on the market.
Hi. I'll present to you 10 features of RENET recuperators that make them so unique. Number 1. An innovative control system. The intelligent mode, in which a synergistic algorithm processes information from built-in temperature sensors, a carbon dioxide sensor, and a humidity sensor, automatically adjusting the operation of the fans to the current needs of the home. And why is that? Thanks to this, the recuperator knows by itself when and how it should operate. This ensures maximum ventilation comfort with minimal energy consumption. Number 2. Built-in Wi-Fi module and control via your phone. No more yet another controller on the wall at home. The built-in Wi-Fi allows for convenient control with any Android mobile device using a specially developed and user-friendly app, which includes, among other things, operating modes for the most demanding users. Number 3. Fully equipped as standard. All RENET recuperators come fully and richly equipped as standard, for example with a built-in CO2 sensor and humidity sensor. Wi-Fi module, constant airflow system, smoothly adjustable preheater, ultra-quiet and energy-saving EC fans, or an advanced control board. All of this is included in the price of the device. Number 4. Modular design that makes servicing easier. The recuperator's design has been prepared in such a way that all the most important components can be easily and quickly removed and replaced, and the control board can be taken out with a single motion. Oh yes! Number 5. Stainless steel housing. A premium class device deserves a premium housing, made entirely of stainless steel. 6. Foam filling. The interiors of the RENET units have no thermal bridges and are made from a material with excellent thermal and acoustic insulation, which ensures high air tightness as well as optimal, smooth, and quiet airflow through the device. 7. Anti-smog filter. The air is what it is, but don't worry. An additional F9 class anti-smog filter in the unit captures up to 90% of suspended PM 2.5 particles. Take care of what you breathe at home. 8. Quick and easy installation. Installation, do it once, do it right, and at the same time, make it easy and quick. There's a convenient mounting system, a maintenance-free siphon, and even carrying handles. Our first startup wizard won't let you do it wrong. 9. Large heat exchanger, also available in an enthalpy version. I'm big, but my heart is big too. The heat exchanger has as much as 35 square meters of surface area and ensures equally high heat recovery. It's also available in a moisture recovery version, where the returning energy hidden in water vapor increases the energy balance by over 20%. 10. The InPrax system. All the software operates within a larger system that allows you to manage various products from the installation industry. The InPrax system is a tool that integrates installation companies, device manufacturers, and their service departments.
When it comes to the RECU series recuperators, we have 3 models: the V recuperator, the H recuperator, and the F recuperator. The V recuperator, which has vertical outlets facing upwards, comes in capacities of 400 and 500 cubic meters, and we also have the option to choose the type of heat exchanger. Will it be a standard HRV heat exchanger, or will it be an enthalpy ERV heat exchanger? It's the same situation with the H recuperator, which comes in 400 and 500 cubic meter capacities, and also offers both the standard HRV heat exchanger and the enthalpy ERV heat exchanger. And we have a third product, the F recuperator, specifically the F350 ERV. So, this is a central unit. It's a so-called ceiling-mounted recuperator, already equipped with an enthalpy exchanger on board. What sets the RECU series apart are RECU recuperators from other devices available on the market. We can divide this into 2 parts: the advantages and benefits for the user, such as the built-in carbon dioxide sensor, built-in air quality sensor, built-in humidity sensor, and the way the unit operates based on these sensors. So, depending on the air quality, the device adjusts its performance continuously, that is, it changes the amount of airflow to constantly keep the carbon dioxide concentration at an optimal level, between 500 and 1,200 ppm. The next component that also benefits the user is the constant flow module. The task of the constant flow module is to keep the air streams on the supply and exhaust sides at the same level, in order to maximize the heat recovery efficiency of the exchanger. And during use, as well as at the very beginning, these 2 streams can differ from each other, because on the supply and exhaust sides, the installations are not the same, meaning they don't have the same resistance. So to correct this, that's exactly what the constant flow module does for us, or during the commissioning process and installation measurements, we have to make adjustments on the fans. The constant flow module is also useful when the filters get dirty, because dirty filters create additional resistance, which in this case the constant flow module overcomes, maintaining both air streams, supply and exhaust, at the same level. Control. Controlling the heat recovery unit via a mobile app, that is, the built-in Wi-Fi module in the ventilation unit, allows us to communicate directly, meaning phone to heat recovery unit or remotely. If the ventilation unit is directly connected to the home's internal internet network, then by simply using a mobile phone with internet access, we can also conveniently control our device from virtually anywhere in the entire world. Automatic bypass. The device, the ventilation units, are equipped with an automatic bypass, which we can use during the summer to cool or chill the building. When the outside air temperature drops at night below the temperature inside the building, for example. Advanced automation. Advanced automation allows us to connect external accessories such as a ground heat exchanger or, for example, an alarm system or a fire control panel. So here, the automation is really advanced and also allows us to integrate with systems like smart home solutions, for example. A mounting system that allows us to install the ventilation unit on the wall, as well as a dry siphon that comes with the device, which protects us from odors from the sewage system getting into the ventilation unit. A PTC-type preheater, which is essentially a sophisticated heater that automatically and precisely adjusts its power output to the current environmental conditions or specific demand, so that during the harsh winter periods it effectively protects the delicate heat exchanger from completely freezing, meaning preventing the blocking of crucial airflow. or even from potential and significant damage or total destruction. As for this automation function, as I mentioned, here we have the possibility of integration with the Forest API Smart Home System, or the option to connect an external doorbell button that triggers ventilation for us, or even an external duct heater, right? Whether it's a water or electric heater, whether as a secondary element, or integration with an external system via 0 to 10 volt performance control, or controlling the dampers on the air intake or exhaust. Controlling the operation of a duct cooler. Digital outputs for connecting to an alarm panel, fire control panel, fireplace button, kitchen hood, and window contact, as well as for controlling dampers or ground heat exchangers, whether air or water-based. I encourage you to review all this information in the user and installation manual. Everything is described there in detail, where and how we can use these features. As for the control board itself, it is designed like a drawer, so we can pull it out from the device, from the recuperator. Double filtration, meaning an additional slot for a second filter, allows us during smog periods, right? So, when air pollution is high, we can install a second filter after the pre-filter. We can install a fine anti-smog filter, or during transitional periods, those allergy seasons, we can also install a pollen filter, which traps pollen that causes allergy problems. The internal frame. The internal part of the heat recovery unit is made of closed cell foam, which provides proper thermal and acoustic insulation, but is also resistant to water and moisture. So even if some condensation were to occur inside the heat recovery unit, it doesn't affect the foam or the internal structure in any way, meaning the internal closed cell foam remains unaffected. We have a choice between two types of heat exchangers, either the standard HRV exchanger or the enthalpy ERV exchanger. As for the exchangers, I will discuss their functionality in the next part. However, when it comes to the Recu series, here we can choose either the standard exchanger or the enthalpy exchanger. Our Easy series recuperators come in two construction versions, the H version, which has horizontal connectors, and the V version with vertical connectors. As for the V version, we also have two capacities available, 300 cubic meters and 400 cubic meters. And right now, we also have different control options available, because we have our Easy standard recuperators, which are controlled via a wall-mounted control panel, and we have our Easy Connect series, which are controlled through an app installed on a mobile device or phone, which communicates with the ventilation unit via Wi-Fi. When it comes to functionality, both the standard and the Connect control exactly the same functions in exactly the same way. So, what else is there, apart from these differences, right? These units, these recuperators, are equipped with an enthalpy exchanger. In the Easy series, there is always an enthalpy exchanger installed, DC fans, advanced automation, and automatic bypass, and also this universal mounting system. As for the options that we can add to the Easy series recuperators, we can optionally add the Hygro Air Quality module, which measures carbon dioxide and humidity. We can also add a constant flow system. On the external duct, we can install an additional filter box or a filter box with a preheater, so these elements are also available as options. Automation. The automation is very similar to the one used in our Recu series, meaning integration with external control systems. Here, in the case of the Easy Connect heat recovery unit, we can also integrate this unit with a smart home system via the REST API. We can also activate the turbo function, which means using a doorbell button. The use of CO2 and humidity measurement modules, as well as cooperation with external CO2, humidity modules, or a constant flow module. And when a measurement module is installed, we can also enable the automatic operation mode in the device, meaning that based on air quality, the device will automatically and smoothly control the recuperator's performance. Or other features, such as controlling the cooler or the secondary heater. Digital outputs for connecting a fire alarm control panel, as well as a fireplace or range hood button, or for controlling actuators and the ground heat exchanger, right? What functions do we actually have when using this control system? So, the functions we have, maybe let me put it differently. Basically, in manual mode, we have 3 speed settings available. To these 3 speeds, we can assign specific performance values, whether that's 30% of maximum output, 60%, or the maximum value. For example, the 3rd speed. Or we can also set up a ventilation mode, which means even more than the 3rd speed. Here as well, in cooperation with the air quality module, we can also activate this mode, the automatic operation, or other modes like the away from home schedule or fireplace mode. And we have the very same essential functions available within our device, that is, Easy Connect, where we can conveniently set and manage all these various functions using the dedicated application on a mobile device. As for the equipment, as I mentioned, the Easy Series recuperators are equipped exclusively with enthalpy HRV exchangers, which, among other things, recover heat, but also recover moisture from the exhaust air. Quick, universal installation. As for our recuperators in the H version, they can be installed on the wall, ceiling, floor, or, for example, laid flat on the floor. The only unacceptable installation is with the electrical box facing downwards. And why am I pointing this out? Because the Easy Series recuperators come in a right or left version. Right or left version means which side of the recuperator the intake duct is built into. If it's the right version, the intake is on the right side. If it's the left version, the intake is on the left side. So when ordering the recuperator, please pay attention to this, because in the H version, flipping the recuperator 180 degrees puts the electrical box at the bottom, which could, for example, result in the box being flooded with water, right? Which can appear in the recuperator. As for the V version, this is an example of installation, right? This is an installation with the vertical connectors facing upwards, for example, I don't know, in a technical room, but we can also install this recuperator in that proverbial closet in the hallway. The installation method for the V version. The recuperator consists of 2 modules, the upper one, which houses the fans, all the automation, and the filters, and this module can be hung up. We can connect it to a wall bracket, while afterwards we can attach the basket at the bottom, which contains the heat exchanger, so this kind of installation can be carried out by one person alone. Additional accessories available for the Easy Series include, for example, a dedicated filter box with a dedicated heater, or just the filter box itself. Just as a reminder, yes, Renet also offers a few installation tips. First and foremost, read the manual and install according to the recommendations provided inside. Why is this so important and crucial? Yes, because, among other things, the wall or floor installation of recuperators from the Recu series is important due to the need for proper vertical and horizontal alignment. There have been cases where water leaked from the drip tray, not draining through the siphon with the condensate, but instead escaping somewhere to the side. Precisely because the device was installed crookedly, not level. Another important issue is the space around the recuperator. We need to leave enough adequate service space for the proper and efficient maintenance of the device, but also enough ample room, among other important things, to easily access the critical control automation board. I've had situations where clients called me about an issue with the automation, for example, when a Wi-Fi module reset was needed, but the distance from the wall was only 10 centimeters, making it impossible to get a hand in or do any work at all. That's exactly why we recommend leaving enough space so that the work can actually be done. So, read the instructions again and follow the recommendations. Here we also have a siphon, because a dry siphon has a gasket inside, and that gasket is held in place by an additional reducer so it doesn't get lost. So before installing the siphon, you need to unscrew that reducer, and only then attach it to the nozzle on the drip tray. It seems like it should be ridiculously simple. At least once a week, I get a message saying the siphon doesn't fit. Peripheral devices that we can connect to the control automation board. So here we have a whole set of available sockets. So starting even with this ordinary bell switch, which we can use for additional ventilation, and here we have a whole list, so control of the ground heat exchanger, control of the secondary heater, control of the heater, control of the secondary cooler, right? Or the possibility of using signal sockets, or connections to alarm system circuits, or to the fire protection system. So here as well, I encourage you to check the installation and operation manual, where all these functions are described, how we can use them, what we can use, and what else we can additionally connect to the ventilation unit. So now we know how to choose a ventilation unit, we know what options we have. Now let's talk about how to actually control such a ventilation system and why we even control it in the first place, right? Indoor air quality is the main parameter or the main task of a ventilation system to maintain proper air quality. In the 1980s, when new window technologies were introduced in Western Europe, right? Meaning plastic windows or tightly sealed wooden windows. When buildings became sealed, a phenomenon appeared that was called the sick building syndrome. This syndrome manifested itself as a high concentration of carbon dioxide inside rooms, or high humidity, which led to health problems for people, and also, among other things, the appearance of mold, meaning the deterioration of, for example, walls or furnishings inside homes. So, to prevent this, the primary and overriding goal of a ventilation system is to remove excess, or to maintain proper air quality in terms of carbon dioxide concentration, that is, to keep it within the range from background levels, where the background is between 350 and 450 ppm of carbon dioxide, up to parameters of 1000, 1200 ppm. This value is kind of a borderline value, depending on the institute that conducted the research. But let's assume that the optimal carbon dioxide concentration, which does not affect us, people, in any way, is exactly that 1000 ppm. Above this value, our intellectual abilities, that is, performing mental tasks or any other tasks, decline, and they can even drop by 30 to 50%. And above the value of 2500 ppm, it's already a level that affects our health and can result in some harm to our well-being. So let's keep the optimal carbon dioxide concentration between the background level and 1000 ppm indoors. The second factor, which is also generated inside buildings, is moisture. When we cook, dry clothes, or do other activities that add water to the air, we can end up with excess moisture, and it's the ventilation system's job to remove that excess. But we also have situations when the air is too dry. So this happens in the winter, when the outside air has, lower humidity than the air inside the building, so we can end up with what's called overdrying, of the air. And the optimal range, for comfort, right? It concerns thermal comfort. Thermal comfort consists of three parameters. That's temperature, humidity, and the air velocity at which air flows through the building. So the optimal comfort range in terms of temperature is 18 to 22 degrees. In terms of humidity, it's 40 to 60%. And as for air velocity, the airspeed should be about 0.2 meters per second in the area where people are present. But now, when the humidity is too low, we have problems during the winter period, meaning our immune system is exposed to viruses. Too much humidity means the possibility of mold and fungi forming on the walls and the spreading of toxins, or more precisely, mycotoxins, yes, inside the rooms, which also affect our health. So besides carbon dioxide, this moisture also needs to be removed. However, these are the elements that are generated inside the building. On the other hand, outside the building, we have air pollution in terms of smog, meaning pollutants like PM10, PM2.5, or PM1 particles, which we can filter out using a filtration system. But noise is also a threat. If we don't have the ability to block out external noise, for example by closing windows or doors in the building, then noise also affects our health and well-being. And for example, here I showed that a water molecule is let me put it differently, a water molecule is the largest molecule that can, for instance, pass through the membrane of an enthalpy exchanger. And compared to other pollutants present in the air, like those PM1 or PM10 particulates. Intelligent control system. The intelligent control system allows the ventilation unit to operate autonomously, which, among other things, translates into the quality of the air inside the building, but also into energy savings, so that the proper operating parameters are maintained inside the building. And just like here, for example, in our RENET units, whether it's the REQ series or the ISI series, we have the option of intelligent control, meaning that based on air quality, the device automatically adjusts its performance in terms of airflow to maintain those parameters at an optimal level. There's also the option to control it via an app that works with the recuperator over Wi-Fi. And here we have these two options, either direct control or control via the internet, meaning connecting the unit to the router and being able to manage it that way. In our opinion, the optimal control is the one based on air quality measurements, because the two previous solutions, manual control, like adjusting the speed yourself, or time-based control according to schedules, have certain limitations that affect the air quality. So, we might switch to a higher speed too late, and at that point, the concentration of carbon dioxide in the building increases, or on the other hand, we might also turn off that speed too late, which generates additional costs due to higher energy consumption by the fans. And, a sort of halfway solution is this time-based control, meaning using schedules. But schedules can also get out of sync at certain times, just like what happened some time ago, right, when instead of going to work or school, people were locked down at home in their apartments, right? How does the smart mode work in RENET ventilation units? So, the device monitors air quality, specifically the concentration of carbon dioxide. That means as the concentration increases, the device's output also increases. We reach the maximum level. The device operates at that level for a while, and when the pollution starts to decrease, the unit also adjusts and lowers its output, meaning it reduces the amount of air flowing through. So that's how it works, based on the carbon dioxide sensor. However, when it comes to the humidity sensor, the device measures the humidity and calculates an average over several hours. But when there is a sudden spike, an increase in humidity greater than that several-hour average, that's when the device starts to react. So it starts removing the excess moisture until it reaches that, let's call it, averaged value. How does that translate to savings? To energy consumption? Because a fan that runs for an hour at a capacity of 400 cubic meters of air will use about 160 watts, while a ventilation unit running for 2 hours at a capacity of 200 cubic meters will use about 86 watts. So, and the effect is the same over a longer period, but it results in lower energy consumption by the ventilation unit, by the fans installed in that heat recovery ventilator. The ability to control this either directly or through an app. The advantage of the system. The advantage of smart control over other options is that we can focus on other activities that bring us pleasure or those we simply have to do. But this device works for us and performs the measurement and adjustment of efficiency on our behalf, which translates into our comfort while staying in such rooms. Break time equals 0.5s/. Example parameters that ventilation units operate on. Users have posted these parameters on websites, so I took the liberty of using these examples. And here we have the opportunity to compare or check how these ventilation units operate under really similar external air parameters. Okay, we've covered the topics related to the way the ventilation unit or the entire ventilation system is controlled. Now we can move on to operation, so we can discuss issues related to the standard HRV heat exchanger or the enthalpy exchanger.
HRV enthalpy heat exchanger with heat and moisture recovery. The heat exchanger is the heart of the air handling unit, which is responsible for recovering heat from exhaust air. The enthalpy exchanger also retrieves moisture, providing greater comfort for householders. 85% heat recovery efficiency means that heat loss is minimal, and the supply air is close in temperature to exhaust air. In counterflow exchangers, there is no mixing of supply and exhaust air streams, which are seamlessly separated from each other by exchanger walls. It is the large surface area of these walls that is responsible for high heat recovery. The walls of the HRV enthalpy exchanger used in RetNet air handling units are made of a durable polymeric membrane that provides a barrier to bacteria, viruses, and contaminants from the exhausted air. And at the same time, it lets through tiny particles of moisture, which transport with them a load of so-called latent energy. Therefore, the total energy recovery efficiency of the enthalpy exchanger is higher than the standard one, and the moisture recovery is up to 65%.
The enthalpy exchanger is a cure for all ills. The enthalpy exchanger is a solution to problems such as excessively low air humidity during the winter season. Because through the membrane of the enthalpy exchanger, moisture passes through as well. So, in addition to the transfer of energy, besides the heat transfer through the wall, we also have the passage of water molecules, which brings something with them, right? Not only do they humidify the air, but they also carry energy in the form of kilojoules, right? In the form of enthalpy. But the enthalpy exchanger also operates during the summer period. If the building is equipped with an air conditioning system, the enthalpy exchanger pre-dries the incoming air before it enters the building. So it works on the principle of transferring from a higher level to a lower one, and during the summer, the outside air is definitely more humid than the air inside the building. If there is an air conditioning system installed there, since air conditioning dries out the air, the exhaust air has much lower humidity, so again, the moisture passes through the membrane from the higher parameter to the lower one. So that moisture is basically being recirculated and removed already at the enthalpy exchanger, from the supply air to the exhaust air. So, initially, the air is being dried. What does choosing an enthalpy exchanger give us? The ability to recover moisture without complicating the device's construction, and the elimination, or rather, the reduction of the problem of overly dry air during the winter season. Lower electricity consumption by the heat recovery unit in winter, as well as reduced electricity use by the air conditioner in summer. Improved thermal comfort for building occupants, reduced air conditioning costs in the summer, and simple, trouble-free operation. Regarding operation, we have filters available that can be installed either in the ventilation unit or in an external filter box. And as a minimum, the quality class of the filter that should be installed in ventilation units is an M5 class filter, which captures 50% of PM10 dust particles. Because in other solutions, or very often clients ask whether they can cut filters themselves or use filters made from G4 filter fabric. But where, in reality, are these filters? These G4 filters only catch the coarsest fractions of pollutants, like sand, hair, or as I like to joke, flies and mosquitoes. But in reality, filtration should start with an M5 class filter, that is, the EPM10 filter, which captures 50% of PM10 dust particles. A quick and comprehensive comparison between the G4 filter and the F7 filter clearly shows that very fine PM1 particles are only captured at a remarkably low rate of just 6% by the G4 filter, while, in stark contrast, the F7 filter effectively captures a significantly higher 86% of these particles. So maybe someone can answer this question for me. What's the point of using recuperator devices that control air quality, or that are controlled by air quality? These devices have heat recovery rates of 85, even over 90%. If, in reality, we're bringing in dirty, polluted air by using lower quality class filters? I'm waiting for an answer. I just don't get it. As for the filters, when it comes to our RecU series devices, we can use a set of filters like the M5 and F9 types without affecting the device's performance. However, if we wanted to use such an external filter box with the easy ventilation unit, we have to take into account that the M5 plus F9 filter set can create resistance at the level of 90 to 100 pascals, so we also need to factor that into the calculations and selection process. When calculating installation resistance, remember filter box adds 100 pascals resistance, include that total resistance. Is it worth using filters? The sample photos probably show that yes, filters do trap external contaminants, but is it also worth using these FSA cone filters? I call them gnomes, or gnome hats, which trap contaminants generated inside the building. So we have a choice, either use filters, or every few years, say 5 or 10, clean the entire system of pipes and ducts. Pressure drop across the mesh. When we discussed the intake and exhaust grills, we talked about the possibility of dirt and contaminants settling on the mesh. So here's another example of such a mesh, where all these contaminants accumulate and we get additional local resistance on that mesh. So the recommendation is, if you have a mesh with fine openings, just remove it from there. As for replacing filters, change them as often as necessary. In my opinion, that's the most honest answer, because depending on the amount of air flowing through and the location of the buildings, these filters can get dirty faster or slower. That's why there's a time-based reminder every 90 days, during which we recommend simply checking the ventilation unit to see if the filters are already dirty, or if they can possibly stay in for another period, right? As for the heat exchanger, manufacturers recommend cleaning it every 2 or 3 years. Wash it with lukewarm water, warm enough so you don't burn yourself adding a detergent, like soap. So basically, just pour that water into the heat exchanger, rinse out the channels, dry it properly, and then reinstall it back into the ventilation unit. In the next part, I'll discuss topics related to the most common mistakes made in heat recovery systems.